Welcome to the Multi-Wavelength Photometry Quick Start tutorial. Today we'll be demonstrating how to do some basic things with the Plexon Photometry software. If your photometry system is not yet set up correctly, you can refer to our hardware quick start guide located on our website, plexon.com. First, before you start recording, you will have to set the recording folder location. In the browsing window, use standard Windows methods to select or create the appropriate folder. The factory default location for the recording folder is Drive Plexon Data. You can create folders and subfolders according to the needs of your experiments. Every time you create a new experiment in the user interface, the system creates a new folder specifically for that experiment. All video files, settings, and data for that experiment are contained in this folder. Now you can create your new experiment. To do so, click on the Experiments tab. Then click the Add New Experiment icon to open the Add New Experiment dialog box. In Cameras mode, the dialog looks like this. The system does not query you for the number of sources because the default number of sources is automatically set equal to the number of cameras currently available in the system and licensed. Enter a name for the experiment in the top line of the dialog box. In the Base New Experiment on drop-down list, select Factory Defaults or Overlay. For now, we will select Factory Defaults. You can learn more about overlays in the Synthesizer user guide at plexon.com. Now we will add some descriptors and variables. Descriptors are for the experiment and variables are for the sessions. You can create up to 20 of each. You can also add an experiment comment if you would like. The experiment descriptors identify the features you consider important for this experiment, such as the test day, information about the test subject, geometry of the test area, dimensions of a maze, lighting conditions, etc. The experiment descriptor names and values must be entered in the Add New Experiment dialog box. However, you can modify them later as needed. For this example, we will just add two descriptors, test day and maze type. The session variables apply to every session in the currently selected experiment and are used later to filter, group, and analyze the recorded data. Typically, they are independent variables with which you wish to compare your test subjects, but you should feel free to add any session variables that are useful for the project. The session variable names must be entered in the Add New Experiment dialog box. When you start a new recording, i.e. a new session, the system prompts you to enter the values for each of the session variables. You can modify session variable values later as needed. For this example, we will add two variables, sex and age. We won't hit the Start Recording button yet, but when we do, we will now be prompted to enter values for sex and age. Click OK, and the experiment will be added to the Experiment tab. Now let us set up object tracking. To begin, we must define our area. Go to the Scenes tab as shown here, and click on the plus icon to create an arena. Next, choose the polygonal tool that best fits your arena and draw the outline of your arena in the behavioral window. We will now set up a zone. On the Scenes tab, click the Add Static Zone to Current Arena icon. The parameters are displayed here for the new static zone. Select the drawing tool that makes the most sense for the zone that needs to be created. Here we will select the rectangle shape. Once selected, you can draw the zone outline over the image corresponding to the first physical zone of interest. Next, we will select our tracking mode. This is the tracking toolbar. It allows you to select the desired tracking mode, either tracking object contour, tracking LEDs, or extended tracking of color markers. When one of these modes is selected, the system tracks the position of the subject in the video in real time. For this video, we're going to select tracking object contour. Since we selected object contour tracking, we will have to configure it for our subject. Place the animal in your camera's field of view, click the Tracking tab to display the tracking parameters. Identify whether your test subject is darker or lighter than the background, and select Dark on Bright or Bright on Dark from the Object versus Background drop-down list. In the Whole Body Visualizations group, check Contour and Fill Contour so that the objects found by the system are visible. If the contour is not well defined, refer to the Synthesizer user guide at plexon.com for more information. Once your arena and zone are set up, you can begin adding events. In the Events tab, select the Add New Tracking Event icon to create an event. In the target row, select the type of behavior to be associated with this event. For this example, we will select Zone. This will trigger the event when the subject enters the zone we have created. Next, select the zone we just created from the Zone drop-down list and define the condition as present in the zone. Statistics for behavioral events will be displayed in the Event Statistics window. Each time the conditions for the event are met, the software will indicate this by highlighting the condition in a specific color. See the brown highlight in the example. Multiple behavioral events can be defined, and the behavioral combo event feature can be used to track when 2 or more events are true. Now that we have configured the behavioral side of this experiment, we can begin setting up the system for photometry. The 3 video boxes display the cameras that are used for detection. The photometry system includes 3 built-in LEDs for excitation and 2 optical sensors which allow for detection of green and red fluorescence simultaneously. The system interleaves the 410nm and 465nm LEDs, and the camera detecting green fluorescence captures light for each of these wavelengths independently, which allows the user to identify the calcium-dependent fluorescence, isobestic control. In the software, the image from the camera detecting green light is shown in the video 465 and video 410 window. The image from the camera detecting red light will be shown in the video 560 window. For each of these cameras, you'll need to define the location of your fibers. First, we will need to define each of the fibers, starting with the 465nm and 410nm windows. Make sure that the Sources tab is selected. You can find the LED current output value here. To change this value, simply double-click the number and type in the desired value. The value for the blue LED is set to 150 mA. You can click the Start button to begin simulation. Next, click on the Fibers tab, then the plus in the upper left corner to add a new fiber. The system will display parameters for a new fiber in the window, and it will place a default circle in this 465nm video window. You can change the name of the fiber here. Note, when adding a fiber, you have to be able to see an outline of your fiber bundle to make sure that you have correctly aligned the fibers you have created in the software. The best way to define your fibers is to hold them up to a bright light. You can modify the position, diameter, and color of the circle in the 465nm video window so that it matches the circular region of the fiber. The number of fibers you have will be dependent on the number of branches you chose for your branching patch cable. For this example, we are using a 4-branch patch cable. We will repeat these steps to configure the remaining 3 fibers. Tip: if you will use each branch in a different brain region or different animals, it is important that you identify which branch represents fiber 1, fiber 2, and so forth. Use a small piece of tape to label the branch for future subjects or session. The windows for video 465 and video 410 are showing the same detection camera, so the software automatically adds the fibers you create to both windows. After adding your fibers for this camera, you repeat these steps for the camera detecting red light. Each time you open an experiment, you will see a note here reminding you to make sure that the key on that patch cable is aligned, and that the cable is hand tightened. If you unplug the patch cable between sessions, you will need to realign the drawn fibers. Next, we will demonstrate how to create photometry events. You can create photometry events based on the relative intensity of fluorescence detected from any of the fibers. Click the Events tab and then the plus button to create an event. Now let us go through the options. Name and color of the event. Here you can select the fiber that will trigger this event. Delta F over F threshold. Here you can enter a number from -1 to +10 for the relative fluorescent intensity you want to define as the threshold. Time threshold. This parameter specifies the number of frames for which the condition must be met before the event is triggered. You can select any number from 0 to 999. Condition specifies when the event is triggered, when the measured relative fluorescent intensity is higher or lower than the threshold. You can repeat these steps as needed for as many events as your experimental design requires. If you are wanting to know when the photometry signal reaches a certain threshold and the animal is in a certain zone, you can create a global combo event. You can do so by clicking the Combo Event tab, then clicking the plus button to add a new combination of tracking events and view the parameters. Select the logical operation to use. Here we chose AND. Select which 2 events you would like to be combined. And your combo event is created. Statistics for photometry and behavioral events will be displayed in the Event Statistics window. You are now ready to start recording. You can now start your LEDs. You may do so now or after you begin recording. If you will only be using one LED for activation, you do not need to start all of the LEDs. You would only start your required wavelength and the 410nm wavelength for isobestic control. Prior to starting a photometry experiment, it is essential to use an optical power meter, for example, the Plexon light measurement kit, to measure the level of excitation light coming out of the branches of the multi-branch optical cable. The photometry software includes a test mode that allows you to test the power output of each LED. In test mode, the LEDs will operate in constant mode rather than pulse mode. To test the power output, first click Start LED Test Mode. Then press the Start button for the LED you want to test. The fibers will start to emit light. Connect the fibers to your power meter and measure the power output. When you have finished, press the stop button to turn the LED off. You can test the remaining LEDs by pressing the start button for each of them independently. When you have finished, to exit test mode, click the test mode button. Test mode is available only when the system is in cameras mode. When you are ready to begin a session, click the start recording button here. Once you have done so, the system will ask you to define the variables for this session. Click here to stop recording. Note that your sessions will be shown in the lower left-hand corner. Your LEDs will automatically be turned off when you stop recording. Finally, we will demonstrate how to export your data. Here we have 3 sessions we have conducted in our experiment. To export specific data, switch to Files mode. Change to View Sessions as Recorded to properly export your data, then you can choose from these 4 options. Export coordinate values per frame single sessions. Export all photometry results per frame for a single session into one file. Export all photometry results per frame for a single session into a separate file for each wavelength. Export events for a selected single session. To export event data for a session, click the Export Events for Selected Single Session button. Then select the events you want to export. Now click to export data by frame or export event intervals. This example shows exported event data per frame. If you'd like to export all of the behavioral data for a single session or a group of sessions, go to the Analysis Parameters tab. Click on the Select one of the user-defined variables to group sessions button. Select the variable you wish to use. Then click on either the Export Analysis Results per Single Session button or the Export Analysis Statistics for Groups button. Thank you for your time. If you have any questions or require further assistance, please email us at info@plexon.com or go to plexon.com for more information.